Okay, so today we're going to be taking a look at Chapter 3.3, homework question number 21. This one is asking for the arc length of the function g of x equals the natural log of the sine of x over the interval pi over 4 to pi over 2. Now remember, our arc length, right, we're going from our interval here, pi over 4 to pi over 2, and how this works is we're going to say 1 plus the derivative, dy dx, we're going to square that derivative, take the square root, and then take the integral with respect to x in this case, because our function is in terms of x, so we're going to do things in terms of x, which means here, this is my y equals g of x. So I'm going to take dy dx, this is my g prime. So if I go to take the integral of this, remember, I take the integral of the natural log is 1 over what's inside, so 1 over the sine of x times the derivative on the inside, which is our chain rule. Okay, so our derivative here is going to equal to the cotangent of x. Okay, this is what I'm going to put right into here for my arc length. Okay, so our arc length, pi over 4, pi over 2, is going to be 1 plus, this is cotangent x squared, square rooted dx. 1 plus the cotangent squared, okay, 1 plus, let's write that down, cotangent squared of x. This is a trig identity. This is one of our Pythagorean identities, okay. This is equal to the cosecant squared of x. So I'm going to plug in for this 1 plus cotangent squared. I'm going to substitute. This is going to be equal to radical cosecant squared of x dx, which is, of course, pi over 4, pi over 2, cosecant of x dx. Now when I go to integrate the cosecant of x, the integral for the cosecant of x is minus the natural log, the absolute value, cosecant of x plus the cotangent of x. And we're going to evaluate that from pi over 4 to pi over 2. This is a little obscure in terms of like the integrals, the trig integrals that we've been trying to learn. Okay, you can take a look at this, right? Look it up, say in a calculus book, or you can take a look online for the integral of the cosecant of x. Okay, typically what we're required to know for our exams are the basic ones like sine, cosine, tangent, possibly even cotangent. Okay, so now let's go ahead and evaluate this. Right, we're going to do our fundamental theorem of calculus. So this is minus, we call it natural log of cosecant of pi over 2 plus the cotangent of pi over 2 minus the natural log of cosecant pi over 4 plus cotangent of pi over 4. Now remember what your cosecant is equal to. So the cosecant is equal to 1 over the sine, and your cotangent is equal to cosine all over sine. So we're going to be plugging in, right, 1 over the sine of pi over 2, cosine of pi over 2 all over the sine of pi over 2, and then 1 over, the sine of pi over 4, and so on and so forth. So when I do this and I add it all out, I'm going to get minus, this minus comes from here, natural log of 1 plus 0, minus the natural log of radical 2 plus 1, that's right, absolute value, and this is in brackets. This minus comes from here. I'm plugging things in, right? So the cosecant of pi over 2 is 1, cotangent of pi over 2 is 0. That's because our cosine of pi over 2 is 0. Minus, that comes from here, our cosecant of pi over 4, right? So the sine of x, the sine of pi over 4 is 1 over radical 2. 1 over radical 2 gives us radical 2. Okay, and then the cotangent of pi over 4 is equal to 1. Okay, so when I put this all together, right, this is going to equal to a minus, this whole thing drops out to 0 because the natural log of 1 is 0. Minus times a minus gives us a positive natural log of radical 2 plus 1. This is just a number. I'm going to leave it in terms of natural logs and radical 2's. Okay, but this is just a number, and that gives us the arc length of this function here along the interval pi over 4 to pi over 2.